Alright, so let's get started here. One of the things you should have learned on Friday was how to solve exponential equations and logarithm equations, and it was the shortcut. So what I showed you on Friday was how to do problems like this, okay? And I showed you the easy way to do it. Today I'm going to show you the more complicated way, but it's still not too bad, okay? You'll be just fine. So let me show you as if you hadn't seen it before. Notice here, I have an exponential set equal to an exponential. An exponential means that where is the variable? Don't think too hard. It's in the exponent, right? That's why it's called an exponential, okay? Now notice that your bases are the same. So we learned this little property that if the bases are the same and you have an exponential set equal to an exponential, then you just set their exponents equal. For example, if I have 2 to the x is equal to 2 to the third, what does that tell me about x? What's it equal to? It's equal to 3, right? So I'm just going to come in here and put a note, x is 3. That's easy, right? Okay, well let's do number 1. I have 4 to the x plus 3 equals 4 to the 5th. Are the bases the same? So what do you do with the exponents? You set them equal to each other, think. So I'm going to put x plus 3 is equal to 5. Now on this one I'm going to have to do some algebra afterwards, but it's not that hard. How would I solve for x here, guys? Good, so I get x is 2. Okay, cool. There you go. That's the general idea. If you have an exponent set equal to an exponent and the bases are the same, you just set the exponents equal. Now look at number 2. Are they the same? No, I've got 4 and I've got 8. Obviously they're not the same. So this is what I'm going to see. Well, could I maybe rewrite 4 and rewrite 8 as a number raised to a power so that I could make it so they're the same? So what number is there that I could raise to a power to give me 4 and raise to a power to give me 8? 2. How so? What power of 2 is 4? Good, so 2 squared is 4. So instead of 4, I'm going to write 2 squared. Now there is still this x on the outside. We'll deal with that in a second. Yeah, and then 8 is 2 to the third. So now do I have a common base? Yep, it's both 2. So I'm going to rewrite this. If you have exponents like that, they're actually multiplying by each other. So this tells me that 2 to the 2x is equal to 2 to the third. Now I have the bases are the same. So guys, what do we do with those exponents? We set them equal. So I'm going to get 2x is equal to 3. And then if I divide by 2, I get x is 3 halves. There's my answer. Now I can check my work by plugging it in. I kind of forgot to plug it in here, but let's go back to number 1. If I plug in 2, I get 4 to the 2 plus 3. That's 4 to the 5th equals 4 to the 5th. Is that a true statement? Yes, we're good. I need your guys' help on number 2. We're going to take 3 halves, or 1.5, and I want you to plug it in. Is 4 to the 1.5 8? Check it on your calculator. Get out your calculator. Do 4 to the 1.5 is 8. Awesome, Millie. Will you try that out for me? Do 4 to the 1.5 is it 8? And it should be, so good job. Okay, number 3 is a little bit tricky. I've got 1 over 25, and I've got 125. Forget that this is a fraction for a second. Let's just think about 25 and 125. What number could I raise to powers to get both 25 and 125? 5 is a good guess. What is 5 squared? 25. 5 times 5 is 25. What's 5 times 5 times 5? 125. Hey, if you have 5 quarters, what do you got? You got $1.25, right? So 5 times 5 times 5 is 125. Okay. Now, 5 squared gives me 25. So then, what power of 5 gives me 1 over 25? How do you make that a fraction? Thanks, Isaac. You do a negative. So I'm going to rewrite 1 over 25. That's 5 to the negative 2. The 2 squares it, but the negative moves it from the numerator to the denominator. Well, what about 125? How are we going to rewrite that? What power of 5 gives you 125? That's 5 cubed, so 5 to the third is 125. So I rewrite 125 as 5 to the third. There is still that exponent of x, but that will just times there. So I'll have 5 to the negative 2 equals 5 to the 3x. Now that the bases are the same, we're going to set those equal to each other. So I'm going to get negative 2 is equal to 3x. I'm just going to show you that real quick. I'm going to set these equal to each other right there. So then, I want to solve for x. What do I just need to do here, guys? Thank you. Divide by 3. So I'd get x is negative 2/3. And I could check that by plugging it in. I just do 125, raise it to negative 2/3. It would give me an ugly decimal, but if I do math enter, enter, I'll change it back into a fraction, and it will be 1 over 25. So guys, your first shortcut when you're solving an exponential is that if you can get it so it's an exponential set equal to an exponential, and the bases are the same, then just set the exponents equal to each other and solve. That's the easy way to do it. Okay, now let me show you the shortcut for logarithms. This is also really easy. Ambriana, will you watch this real quick? Because this is going to blow your guys' minds. If I have a log set equal to a log and they have the same base, then watch what I can do. I'm going to take my pen and just cross out the logs. Isn't that great? If you have a log set equal to a log and the bases are the same, then you just set the arguments equal to each other. I'd say 2x plus 3 is equal to 7, and then I would solve. Now, let's actually go back a quick second. First off, when I say ln, what does that mean? It's a natural log. Good job. Do you remember what the base is in a natural log? It's the number e. Good job. So natural log is base e. So they have the same base, so I cross them out. Now I'm just going to do some algebra. Isaac, help me out here. Well, how would I solve for x? Yeah, subtract that 3 on both sides, so I get 2x is 4. Keep on rolling. So I get x is 2. And that makes sense because if I plug it in, 2 times 2 is 4, 4 plus 3 is 7, ln of 7 equals ln of 7, and there you go. Okay, this is what I teach how to do on the Friday lesson. Now, if you haven't watched it, you still need to go back and watch it, okay? Because this is a quick overview, but there's a lot of other things in there and a lot of practice for you to really learn. Okay, now what I'm going to show you today is how do we solve logarithms and exponentials if I can't use a shortcut? Well, there's going to be 4 steps. You're going to isolate, you're going to rewrite, solve, and check. And I'm going to have those written down for you, so you don't need to write them down, but that's what we're going to be doing, all right? Okay, now, let me just go over your calendar super fast. Today, we're going to go over solving day 2. I'm actually going to give you the solving quiz next time, and then we're going to review for your test. Now, technically, the next time I would see you after Thursday would be Monday, but Monday is our quarter cutoff, which means if you take the test for your first time on Monday, you only get 1 chance and no retakes. So I think we talked about this already, but here's what you're going to do. After you review on Thursday, you're going to take your test the first time on Friday when you're at home. There's going to be 3 parts. You take all 3 at home. Now, what if you don't do so well on it the first time? You're going to retake it in class on Monday. So you'll try to use the weekend, do 1 attempt, learn from your mistakes, and then in class, you're going to try it again. What if you do really good the first time? Do you have to retake it? No, but what is really good in my definition? above a 3. There you go. So if you get like a 2.5, you're like, I'm okay with that. I'm like, well, I'm not, so take it again, okay? Okay, now with Monday being the quarter cutoff, that also means that you need to make sure any missing quizzes or tests or anything else that you're trying to get your grade up with is done by Monday. I'm available today after school. I'm available Thursday after school. I'm also available before school. Come and get help. Don't show up on Monday because I'll probably have a line of people waiting to the last minute to get help, and I won't be able to help everyone, okay? Cool beans, do you have any questions? Okay. Well, let's keep on going. Who's got a joke? We need to lighten things up a bit. An appropriate joke. What was wrong with the plant in the math classroom? It had square roots. Yep, that's a good one. What do you call a smart bee? A spelling bee. Oh, another bee joke. What kind of bee doesn't like Selena Gomez anymore? Justin Bieber. Come on, you can at least give me a smile on those masks. I can tell when you're smiling or not. Okay, we're going to move on, okay? But hopefully you're awake a little bit. What we're doing now, guys, this is how you solve exponentials if you can't do the shortcut, okay? You're going to go through your 4 steps here. Let's read those 4 steps. Braylon, will you take the first one?
Isolate the exponential.
Awesome. What does the word isolate mean? Get it alone, all by itself, okay? Louise, what is step 2? So remember when we did the intro to logs and exponentials, we practiced going back and forth, we're going to use that here. Isaac, what is step 3?
Solve for the variable.
Just use some easy algebra and solve, and then Caleb, what is 4?
Check.
Okay, check your solution. How do we check it? Just like what we did, you're going to plug it in and see if you get a true statement. So let's practice this. Okay, here I go. 6 to the x minus 6 equals 42. My first step is to isolate the exponential. Which of these is the exponential? The 6 to the x, right? It's the only one that has an exponent. So that's my exponential. I want to isolate it. Is it isolated? Nope, because it's got this minus 6. So what would I do? The very first step to isolate it. That's 6. So I get 6 to the x is equal to 48. Now let's practice doing what we did last time. Like on the warm-up example, could I get these to have the same base? Let's think of powers of 6. What is 6 squared? What's 6 times 6? 36. Not 48, right? If I did 6 cubed, I'd get 216. So can I rewrite 48 as 6 raised to a power? No. So then what do I do now? Well, I'm going to use these steps. So we isolate it. And now we need to rewrite this as a logarithm. Maybe you need some practice here, so I'll do this for you. But if I have an exponential, the way I rewrite it as a logarithm is I set the exponent equal to the logarithm. So I'm going to do x equals log. And this 6, notice how it's in the base of the exponential. It's going to go to the base of the logarithm. And that 48 is going to come inside. It is now our new argument. Remember, what's inside is called the argument. So our answer here is x equals log base 6 of 48. Now, let's say you're asked to plug in an answer here. How do you put this into your calculator? Remember what buttons you push? You're going to do math up, and I want you to put in log base 6 of 48, and let's go to 3 decimal places, round that out to 3 decimal places. What do you guys get log base 6 of 48 is? 2 point, would it be 161 if you round it? Okay. But there we go, so it's about 2.161. That tells me that 6 raised to that power is going to give you 48. So now what I would do is I'd go back to the beginning and I would check that. I would do 6 raised to 2.161 minus 6 equals 42. Now when I actually go and plug it in, it's going to be off just a little bit. Why is it going to be off just a little bit? Well, did we round here? This number just kept going and going and going. We said, I don't want to write down the whole thing. So by rounding, my answer will be off just slightly, but I expect that to happen. Okay, so that's how you do this. We isolate, rewrite, and then we solve. This one, it was actually already solved for us, so we didn't have to do any work. And then I could plug it in and check my work, and we're good. Okay? Let's go and do another example. Okay, let's get some help from you guys on this one. Okay, so let's go to Maddie. Maddie, what is the exponential on the second example here? 3 raised to the x. Good. Is it alone? It's not. How would you get it alone? So that'd give me 4 times 3 to the x equals 36. Good. Then what? Uh-huh. What's 36 divided by 4? 9. Alright? Okay, now can I show you where people mess up on this a lot? They'll say, oh, 4 times 3 to the x, that's 12 to the x. You can't combine those, okay? Because, do you remember, please excuse my dear Aunt Sally, PEMDAS? What does a P stand for? Parentheses, what's the E? Exponent, and then we get to M, which is multiply. So we have to do exponents before we multiply. So the exponent needs to go first, so I can't multiply until we do the exponent, so you can't do anything there. Okay, does that make sense how I got to here? I isolated by just, we subtracted 2 divided by 4. Okay, now guys, you could actually probably figure this out. What power of 3 gives you 9? 2. 3 squared is 9, so I know I'm going to get 2. But let's just practice on this. So, remember I gave you an example here. 6 to the x equals 48. The exponent is what you set it equal to. The 6 went into the base, because it was in the base of the exponent, now it's the base of the log, and the 48 came in here. So how would I rewrite this as a logarithm? Except what's our base going to be on this? Log base 3, there we go. So it's a different base of 9, and there we go. And if you plug that into your calculator, you'll get that that is 2. Because what power of 3 gives you 9? 2. So that's how you do that. So now, let's check that. I'm going to come and plug 2 in up here. 3 to the 2 power, what's 3 squared? 9. What's 9 times 4? Plus 2? 38. Does it work? Yes. Awesome. Hey, one other thing I just want to throw out there. Can you use your notes on your quiz? Or on your test? The answer is yes, you can. So for those taking notes, good, because you can use those. So if you're not taking notes, we'll start taking notes, because you can use them on your test. You might as well have something to help you. Let's go to other ones. They're going to get just a little bit trickier with more algebra steps, but the basic idea is the same. We're going to isolate, rewrite, solve, and check. Okay, so Jade, help me out on this one right here. What is the exponential? So this right here, this is my exponential, right? So how would I isolate that? It's already, that's what that dot means, is I'm going to 6 times that. So we need to do opposites. What's the opposite of timesing? Dividing, right? So adding and subtracting are opposites, multiplying and dividing are opposites. So I'm going to divide by 6. Now this is where people are like, wait a minute, why are you dividing by 6, 19, and 6, they don't divide evenly? Well, then we're going to leave it as a fraction, okay? So the 6's simplified. So now I've got 3 to the 10x plus 7. That's equal to 19 over 6. Alright, now, that was step 1. We have now isolated the exponential. What does step 2 say? Rewrite as a logarithm. So, notice the 10x plus 7, this whole thing is the exponent. So I'm going to write this. 10x plus 7 is equal to, you set the whole exponent equal to our logarithm. So guys, help me out. What is going to be the base of the logarithm? 3. And what is the argument? 19 over 6. Just like that. So now we have rewritten the logarithm, or rewrite the exponential as a logarithm. Are we done? No, we still have to solve for x. I have 10x plus 7 equals that. Okay, so let's send this to Louise. What would I do, Louise, from here to get x alone? Yep, let's do that first. So when I do that, I'm going to get 10x is equal to log base 3 of 19 over 6 minus 7. And then what would be my last step? Still solving. The 10 is timesing by the x. What's the opposite of timesing by x? Or timesing by 10 is divided by 10. Okay, now if you were to put this in your calculator, there's a million ways you could mess up on this. So I want to go over it with you, how I would do this, so that you make sure you get the right answer. So does everyone have their calculator out? Let's get everyone. I want you to put in log base 3 of 19 over 6. So you're going to go math up, log base 3 of 19 over 6. Just plug in that part and tell me what you get. 1.049 is what Caleb got. Do you guys agree? Okay, what should I do next? Do I subtract the 7 or divide by 10? If I'm plugging this in. I just did this. What's next? Minus 7. And actually do minus 7 and push enter. I got negative 5.95. Now divide it by 10. So negative 0.595. Is that what you got? Yeah, I want to walk around to see like negative 0.595. Good. So that's good. Okay, so that's the problem is this is, it's dividing just the 7. That's why you need parentheses there. So if I were plugging this in, I would just do it one step at a time. I would do that, minus 7, divide by 10. Because if you put it all in together, you might forget parentheses and mess something up. Okay, if I wanted to check my work, I would go and I'd plug that in, and guess what? I already checked it for you. It works. Cool beans? Okay, we're going to finish off exponentials, and then we'll take a little break after that. Let's just go over number 10 together, okay? So on number 10, I'm going to get some help on this one from Nellie and Angela. Nellie, you with us? Oh, that might be tricky. Nellie, will you be awake on this one? Thank you. Angela, you're going to help me out on this one too. Hey, so looking at that, what is the exponential? What is the thing we're going to try to isolate first? There we go. So I'm going to come over here and just highlight that. We want to isolate that. Well, the problem is it's being times by 10, multiplied by 10, and added by 3. So Angela, what's a good way to undo those things? What would be a good first step? Good, we're going to do that, but first let's get rid of that 3. How would you, what's the option? Yes, let's subtract that 3 first, because I don't want to have to divide it by 10. Then we'd have fractions, and that wouldn't be fun. So good, so minus 3